Release the Kraken!
Welcome back, fellow game designers. In our last tutorial, we went ahead and created our block placement code, so we can place blocks into the world here. And in this one, we are going to kind of fix it because, well, there's some broken things about it. Alright, so let's go ahead and jump into our player controller. And the last thing we set up, if I come up here, is our place block code, and we added in our place location, which is derived from this world conversion that we have here that splits the world up into 64 by 64. Okay. So the first thing I want to do is make it so that we can actually see the block that we place. So I'm going to come over at the end of our placement here, so our place location, and drag off of there. Let's do a debug box. And I'm going to change the line color to something that I like. I'm going to choose red. Okay. And then the center is going to be from the place location. So I'm going to go ahead and plug that in. Now the extent is going to be the size of our cube, but we can't do the entire size because our cube is being drawn from a center point. So for example, if we were to take our center point, right, our cube is going to be drawn from the center to some distance out. And then some distance up, and some distance down. Okay, kind of like the radius of a circle, you know. So we want to take the entire distance. We want to have that, and then we'll end up with our square, or our box in this case. So we could just type in 32, and if I compile it and play it, now whenever I scan the ground here, you will see we get an outline for the box. And then whenever I click, that's where the block ends up being placed. Awesome. But we don't want to hard code this, because what if we decide to change our block size later on? Well, then we'd have to come in here and manually do that. Luckily, we wrote the code for this over here, which is right here. We actually put this in the wrong spot. So I'm gonna borrow this. So Control C. And then I'll go ahead and delete this off. Now we can plug our block size right into here. That's fine. We want our division to be over here. I'm going to plug that into our extent, like so. So now our block size divided by 2 should give us our extent. And as we go to place the block, we are good. Now another thing you might notice is on my screen, my block is kind of hovering. Yours, it might be sunken in. It really depends on where the floor is. So let's go ahead and scrub out this floor to make life a little bit easier. I'm going to go ahead and grab this floor piece. Let's just go ahead and nuke that. Now all I'm going to do is I'm going to drag my block into my world space. Let's go ahead and set this to 0, 0, 0. Later on we'll make a spawner for this, but for now this will work. I'm going to go to my perspective. Let's go down to top. Find out where that block is. Just going to duplicate a bunch of these. Let's change the grid to 1 and make sure the grid is checked. Or it should be orange. You know, you don't want to be empty there. Now hold down Alt and just drag. Make sure the lines are touching. My mouse is getting kind of old, so it double clicks. All right, I'm going to go to my outliner here, just kind of grab all those blocks. Just going to extend this just a little bit so it's not super tight. That should be good enough. If I spawn in, it should be at the exact height that is necessary for the blocks, which is great. Hey, that mostly works. There is a problem with this setup, and I'll show you what it is. There's the first one. At a certain distance, I'm selecting a block too low and then able to place it. You don't want to place blocks inside of each other. And the other thing is, as I'm scanning this block, you see in the right corner of my screen that it's trying to say that that is the position for this block, but that's not the position for this block. It should be right here. Now the reason for that is, as it's scanning, it's doing a little bit of math, and it's adding itself back to itself. And I'll kind of show you in the math here what that's doing. So I grab a print string off of this. I'll do an append. Make a couple of these. So for B, I'm going to do a space and then double bar. Let's hold shift and hit the backslash twice. I'm just making a spacer. It doesn't really matter what you put in there. I'll do the same thing for this one. I'm just doing a space before and after. Okay. So to kind of show you how the math is breaking down, we have our world location. So I'm going to plug that into the first one. And then I'm going to also get our look at location, which is going to be the conversion of this. So let's drag this one in right from this one's extra. And then the last one will be from our place location, which I will just drag into here. Okay, so our three values. So we have our look at location, we have the world conversion that we're doing, and then the place location, which is this added back to the world offset. So if I run it and I scan, you'll get a print out of a bunch of numbers here. And if I find a spot, let's say this guy right there. So you can see, as I aim my mouse at this position, we have, in the first X, we have 223.9, and then the Y is 70.55, and then the Z is 72.75, or 77. So if we take the 223, and we divide that by 64, which is our distance, we get 3.49, right? But we truncate this number. So this part gets cut off, which leaves us 3. Okay, so we end up with 3 times 64, which gets multiplied back. This is our world conversion. So times 64. That gives us our 192. And we take our impact normal and we multiply that by the size of our block, which gets us 1 times 64, and then we take that number, we add that back to this 128 here. What ends up happening is we get a negative number, and that negative number gets subtracted. So this should be 192, but you can see if I subtract that, if I try to subtract 64 from that, we get the 128. And if we go into the game here, bum, 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 bum. Let's add a spot just so you can see it. So if I take the impact normal, just drag off of one of these dots here, just so I don't confuse you, we're not taking this number, we're taking the direct impact normal here. So what this does, it returns a whole value, either 0 or 1 or some fractional number in between to kind of get you an idea of which direction you're facing. So, play. You'll kind of see that here. So at the very end, you'll see x is 0, y is 0, and z is 1. If I place a block, and now I scan from that block position, you can see that from this side of this face of the block, I have a negative x. So I'm on the back side of this block. And if I, oops, move too far. So I've got a negative x. If I go on this side, that is the positive 1. If I go on this side, we have a negative 1. This side is a negative x. Or sorry, that one's a positive x. Right. And if I place a block, let's say there, if I scan in front of that block, we should have, if we look at the third column of number, or the third section of numbers here, the correct position is 192x, 64y, and 64z, because we're 64 off the ground from 0, and we should be 64 off axis from y, which is correct. But if I scan the block, you can see it pushes us back a bit. And that has to do with the fact that it's thinking, if you look at the very last column of numbers, we have our x, which is negative 1. So negative 1 multiplied by our block size gets us negative 64, and we end up adding that back to our 192, which is the second column of numbers here, which is the position of the actual block. So that's where our hit scan is after we've converted it to world position. So that 192 plus a negative 64 gives us a positive 128, which is why it's skipping a block, which isn't really good for what we're doing. So that causes a problem, right? But the simplest solution really is to, instead of converting back in the world space and kind of figuring that out, we could just check to see if we're in contact with another block and find its center position, which is what we're going to do. Let me go ahead and get rid of this chunk. You might not even have this. This is left over from me experimenting. And we can get rid of our text. We don't need this anymore. Now I'm going to get rid of these bubbles. So let's go all the way back here. And then off of our hit actor, we can pull out of this. We'll just go ahead and cast to our block. So cast to block. Let's move this forward. We're going to cast up. So if we hit something, we're going to cast to our block. If the thing that we scan is not a block, then it won't matter. If the cast is successful, instead of taking the location that we've just scanned for, we are going to actually scan for the location of the block. So I'm going to get actor location. And this is going to work out fine because we're never going to have anything that's not really a block that is set up on our grid anyway. So that'll pass directly into our lookout location, and we'll take the top value and plug that in. So if our cast is successful and it is a block, then we'll get its location and we'll set it. We should be able to compile and save. Hit OK. And now we should have no problem drawing a block directly to where we want. Hey! Okay, and that should wrap it up for this video. Nothing too crazy. Nice and short. Hopefully you found this one to be educational. Stay tuned, and I shall see you next time. Hey guys, thanks for checking out my channel. Misty and I both thank you. If you enjoyed that video you just watched, make sure you hit that like button and subscribe. Also, if you'd like to support the channel, check out my Patreon. I also have a Teespring store where you can get official Lame Duck Studios merch, hoodies and t-shirts and that sort of thing. My usual posting schedule is I create new content on Sundays and I release content on Wednesdays. With the summer kind of rolling out, I'm getting back into the usual schedule, so stay tuned, and I shall see you next time.